Okay, a few quick things to start is try lockdown. And if you have technical issues, okay, report to our IT support first. Okay, the thing is, there's not that much I can do from my side on lockdown. So basically in this, my duty is to type in the questions. Once that is done, pretty much my job with lockdown is over. So the rest we have to rely on technology and our IT support. So if you have technical issues, the first thing you should do is actually call them. In particular during our exam. Okay, for practice probably it's okay. You can email, you can wait. When you are actually writing the first exam and all other exams, and if you bump into any technical issue, please call them. Okay, so call during exam. What I can do is afterwards, once you are able to, hopefully you are able to identify the problem. Like in particular, if the problem is not from your side, then obviously I will accommodate. Okay, but if possible, try to save all the evidence. Like if you could then submit, you can use your phone to take a photo. And if there's issue, you couldn't do the question, you take a photo. Right. The most important thing is if you have problems, so take a photo. But in general, what I want is keep evidence, okay? Because that's important. My role here is to maintain a fair environment for each and every one of you, okay? So if you do have problems, it's technical issues, of course, I will rearrange the exam. So let's say you are 20 minutes into the exam, okay, and then something happened. Of course, I will give you additional 55 minutes, afterwards to somehow make up the loss. So once you can prove, and once everything sounds reasonable, of course, I will accommodate. Okay, take a photo or video to keep evidence. Okay. What else? I think that's pretty much all I have for the. Another thing is, if you think an exam question, okay, has issues. I mean, the question itself has mathematical issues. Okay, what I can tell you is treat it as no problem. What it means is, in the end, if you are right, the problem itself has issues, then all of you will get the points. Okay, so there's no need to trying to contact me to say, okay, question 3 has problems. There are issues with the formulation. I couldn't find any correct answer from all 5 options. Then you should treat, or at least think, you might have done something wrong. Okay, the question itself is correct. Okay, and even in the end, that assumption is wrong. All of you will get points for that particular question. So there's no need to worry about that. That's everything I have for the basic issues with the lockdown. And now let's do the practice exam. First, not only for this exam, for all the exams you're going to take in the future, the first thing you do once you get the exam is to read the instructions. Trust me, at least 50% of you never seriously read instructions. At least 50, and usually I would say that number is surprisingly big. Most of you think once you get the exam, I will need to go to question 1. That is the wrong attitude to start, because you might be missing something very, very significant. For instance, here I say, if none of the 5 options match your result, choose the closest one. Instead of, okay, am I doing something wrong? Is the question wrong? And so if you read this, you would know it is possible that all 5 options are not exactly correct. If that is the case, you should pick the one that is the closest. Okay, so you should know the mathematical meaning of closest, right? Not rounding up, not rounding down, but the closest one. So for instance, I have an example down here. The right answer is 5.3. Okay, I'm not asking you to round up to 6 or round down to 5. Nothing about that. So what we need is the closest one. Okay, so from 5 options here, obviously this is the closest one, right? So that's what I want. Okay, I want you to find the closest to what you think is the correct answer. Okay, and here I give you some notations. Right, there are not many instructions, so go through this quickly. Now let's actually do the question. So what we will do is I will finish all 30 questions, and then I will take your question. Okay, if you have any. The first one. How much do you need to deposit today in order to receive $1,000 at time 1 year and $3,000 at time 4 years? Assume the effective rate of discount is 4%. So when you do the question, right? So you should know you are trying to look for the value at time 0. You receive at the end of 1 year $1,000. At the end of 3 years, $3,000. Okay, and the effective rate of discount. See, that is my step 1. My step 1 is to draw a timeline and convert all the information into mathematical forms. For instance, this timeline represents the first sentence. Right? So the question is here. I put a question mark at time 0, meaning I'm trying to find out the value at time 0. Okay. And 1 and 3 simply refers to the money flows. Okay, 1,000 and 3,000. The last sentence gives me the D is 4%. It is D rate of discount, not I. Okay. Once you know D, we know V. Right? V is the discount rate, so it's easily 96%. And then what would be the PV? So the first $1,000 I need to discount back by 1 year, right? So from here to here. And the second payment will be discounted for 3 years. Right? Of course, this is the standard step, right? So once you are familiar enough, I believe a lot of you can directly get to the last step. By the way, this is somehow what I saw from some of the practice question submissions. Some of you did. That's great. So I can see how you process, how you learn. Many of you can directly get to this step. That is good. But still, it doesn't hurt to write this down. It costs you additional 20 seconds, and that 20 seconds will help you the long run. Okay. But of course, if you are at the advanced level, you can directly get this. I mean, you don't even need to write it down. Right? You can after you finish reading the question, you can use your calculator right away. Okay. Try the answer. Okay, you should get a number. Suppose the force of interest is given by this form. Sarah makes deposit of $100 at time 1 year and another deposit $200 at time 3 years. What is the accumulated value at 5 years? So we do the same thing. So at time 1 year, she deposits $100. At time 3 years, she deposits $200, and we want to know the accumulated value at time 5. Okay. So first of all, we need to know the general AVF. So let's say from S to T. So you start from time S, you end at time T, you integrate for your force of interest. Let's use U because I don't want the arguments to coincide with each other. So this is the general formula, right? So now we have 2 payments. The first one is 100, and it goes from time 1 to time 5. The second one is $200, and it goes from time 3 to time 5, right? And then you do integral. So for instance, let's do this general form. From S to T, 0.01 U du. So here you will get obviously 0.01 divided by 2, and the U goes to power square, right? So the U square, and then you plug in those two values, that will be T square minus S square. Okay, so this is the general form. So in particular, what we have here. So this is 0.005 times, this is a 5, not T. So it's 25 minus 1, it's actually 24, plus 200 times exponential 0.005 times 25 minus 9, so it's 16. So if you want, you can write this, right? And then punch the numbers into your calculator. You will get a result. C. Okay. By the way, the first one is B. Okay. The second one, the result I have is 329.4071. Okay, you found something between, so it will be between those two. Okay. Today is January 19th, 1990, and Jack invests 500 in a short-term security that pays simple interest at 8% per year. How much will he receive if he sells the security on May the 10th? So this is day convention because this is something happened within a year, and we have 2 dates. We want to know the time between those two. So number of days. So the number of days in between will be the ending day minus the starting day. So that's the difference of the days times, because we apply 30 days a month, so it will be 30 times how many months in between, right? So we apply 365 a year, but obviously that's not that too important in this formula because they are the same. So this will cancel. The first one, you actually get a negative number. That's okay. And then you have 120. So you have exactly 111 days according to this formula, 365 rule. Okay. Now we want to know what is the T. So you use your number of days divided by the number of days in a year, which is 365. I can give you a different rule. Say I can give you 360, then here you will need to divide it by 360, right? And sometimes I can even give you actual. So you will need the actual number of days in a year. Okay. Then we calculate how much he will receive, which means it's the accumulated value. You start with your principal, 1 plus Ti. T is this number, and I is simply the interest rate, right? So it should be straightforward. So you get about 1, 5, 12, right? So this is the answer. Question 4 is the SOA question, meaning it's slightly difficult. A deposit of X is made into a fund which pays an annual effective interest rate of 6% for 10 years. At the same time, half X is deposited into another account which pays annual effective rate of discount D for 10 years. We know the amount of interest earned is the same for both funds, calculated D. So basically this question tests you the understanding between I and D, right? So we can do the first one. So this is your present value, right? X is the present value, time 0. Then we want to know the value at time 10. The difference between them would be the interest. So this part is actually very easy to do. It is 1 plus I. I here is 6%, so I'm going to plug in the values, and I accumulate for 10 years. So this is the interest earned over 10 years. Okay, I believe this should be somehow easy. On the right-hand side, we have another fund. Originally, it's half of X, right? So we need to know. So we already know the original amount. So we're trying to figure out what factor we need to times by. All right. So right now we have D. We are trying to get interest, and but is the interest is the same, right? So future AV minus PV is interest, right? You borrow $1,000 today. In 1 year, you pay $1,050. What would be the interest? Right, so the $1,050 minus 1,000. That is why you need to do the minus part. Minus part is the interest amount. Now the question is, how do we figure out D? I think we already did in question 1, right? So once you know D, you know V is 1 minus D, right? Once you know V, you know 1 plus I is 1 over V. So this is 1 divided by 1 minus D, right? So with that in mind, we know, or if you want, you can write this in negative power if you want, okay? So this is 1 minus D, okay? Negative 1 is for 1 year. Now we need 10 years, so it's negative 10, right? This is the formula, right? I just derived for you one more time, okay? Obviously, X can be cancelled, right? So we have 1.06 to the power of 10th minus 1 divided by, I can times 2 to the left hand side. So I have 1 minus D to negative 10 minus 1. Okay. Now it's time to get your calculator. Get this one to here. Right, and then take the entire thing for negative 1 over 10. Then I will get 1 minus D. So finally 1 minus this number will give me D. Okay. The answer I get is about 9%. So A is the answer. Okay. Even you don't know how to solve this mathematically, you can always plug in 5 options to the right hand side to see what value is correct, right? I mean, I don't want to see that, but if you really have issues solving this equation, you can plug in A, B, C, D, E. Okay, start from the middle one, because that gives you probably an easier way to figure out the correct answer. Here we have 2 important results. So not 2 important results. We have two numbers for annuity. This is the first one is annuity immediate. The second one is annuity due. We want to know the number of payments. Okay. You cannot directly use your calculator. That's because I is something you don't know yet. Okay. So we know annuity due, it's simply all the payments moved 1 period ahead or 1 year ahead, which means you just need to accumulate for 1 year, right? This is the AVF for 1 year. So from here, you easily know if I use this number divided by this, it would be 1 plus I. From here, I know I would be 4.5%. At this step, if you have a financial calculator, you should be able to easily get N. Okay, but that's not something I want you to do. It's a shortcut, by the way. It will save you time. But from the learning point of view, that's not a good thing. So we can use either one of them, because now is 1 minus U to negative N. So U would be 1.0 V 1.045. So it's negative N divided by I is 0.04. Okay. So now you can times by this. Okay, 1 minus, move to the other hand side. I get this is 1 minus 7.9127 times 0.045. Okay, then I need to take logarithm on both hand sides. So negative N will come out. This entire thing take log, right? And then I divide over to get negative, to get N. Okay, the result is 10. So this is one of the things I call concept questions. Okay, you may need to do some kind of analysis, but not direct computation, because I'm not asking you for a result. I'm asking you for a formula. So consider a special annuity that pays $5 from year 1 to year 5. So we have $5. Okay, $10 from year 6 to year 12, and then 15 from year 13 to year 20. Okay, assume all the payments are made at the end of the year. Which of the following are the correct expression for the present value of the annuity? This type of question is actually challenging because it's quite easy to misunderstand one of the choices. Let's start with the first one. Okay, so 5A20I. So what is 5A20I? So I have payments for 5 over 20 years, right? So that is the first one. Okay, and then let's do the second one. I will use a different color. Then I have a discount factor 5, which means I need to move to here. Okay, then I have another $5 for 7. So here it would be 6. So I put the value down here. Okay, so 7, 6, not 6. It's $5. $5 for how many? For 7. If you want to count, you can, but you should know, you should end at here. Right, so this takes care of the second one. Okay, now let's use another color. 12. So this point now is at here. You discount. Okay, you have 8 payments of amount 10. So starting from 13, you will get $10, and you continue for 8 payments. I know it will end at here. If you don't know the easiest way, not exactly that triggers, okay, you count, right? You start with 13. So it's 13, 14, 15, you count 8 numbers, and you end at the 8th number, which is 20. Okay. Another way is you start here, okay, 13. 13 is your first payment, meaning 13 is equivalent to 1. So how do you get from 13 to 1? So it will be 13 minus 12, right? So then 12 add by 8 gives you 20. Okay. So those are all the payments. Let's say whether they match. Okay. So I have $5 from 1 to 20. Okay. So that takes care of this, right? Okay. And then I have another $5 from 6 to 12, meaning in this period I actually have $10. Again, it matches my information. Finally, for the last period from 13 to 20, I have $10 plus the original, so I have $15. So perfect. That's exactly the original condition, right? $5 for the first 5 years. And then I have $10 for the next 7 years. And then I have $15 for the final 8 years. It's exactly what I have. So the first one is correct. This is how we solve this type of question. Okay. Of course, this is the next one. Actually, is easy to understand. This is directly the information, right? I have $5 for the 5 years. Okay. Then I have $10 for the next 7 years, but it is deferred by 5 years. Finally, I have $15 for 8 years, and it is deferred by 12 years. So the second one, is actually very easy to derive. Now let's look at the last one. Okay, it's actually more challenging for the last one. So what we still have this part is the same. I have $5. $5. Okay. And then starting from the 6, so here let's put a different color. So this is what they discount. And if you have annuity immediate, which means the payment starts the next time point, you have 10. Okay. From 10, okay, now you have 15. So where do you end? 6 is the first payment, and you want 15 payments. So it's 15 plus 6 minus 1. So you will actually end at 20. Okay, you have a total of 15 payments, and then you minus. Let's use the third color, and it will be you minus. Still is the same, but it's minus. Still the same point, but now you want to minus $5 out, and you are going to continue for 7 years, which means you are going to end at year 12. Okay. Now, let's do a comparison with the original one. Are the payments the same? Yes. Right. You have $5 from 1 to 5. Okay. Starting from here, you have $5 from the pink, -5 from this brown, so they cancel, which means leave you with $10 for the next, that's 7 years, right? So finally, for the final 8 years, you have 5 from the pink, and you have 10 from blue. Together, you have $15 from 13 to 20. Exactly what we see down here. So all of them are correct. So D would be the answer because all of them are correct. Okay. 7. Andy pays this amount for a 10-year annuity immediate now that gives him payment 100 and the extra lump sum at time 10. So basically this is, we have an annuity paying $100 for 10 years. Okay, and at the final time, we have another payment of 1,000. Okay, we want to know the effective interest rate. The present value we know. So what we do is we write down the present value, which is directly given. On the right-hand side, we want to convert all future cash flows into time 0. Right, this takes care of the annuity part. Right, it's a simple annuity immediate. You have one lump sum payment. It's paid at time 10, so I need to times by a 10-year discount. Right. Okay. So now the question is how we're going to solve this. Again, if you have a financial calculator, it can directly give you the answer. Okay. But if not, no, that's not 1.5. The answer is actually 5%. If you have a financial calculator, you can directly hit the corresponding buttons to get this. But in case you don't, in case you only have a regular calculator, so what would you do? Well, you simply expand this. So it's 1 minus V to -10. Not -10. It's +10 because I put V divided by I plus 1,000 times. We can write this -10. How do I get my eraser? So let's write into I because I is something we're looking for. Okay, so we can try, right? So plug in the middle one. I will get the right-hand side is about 1435, 199. So it's bigger than my left-hand side. Right? What it means? It means the interest rate is too low. Right? The higher the interest rate, the less annuity is worth. If you want to bring the right-hand side down, you're going to try a bigger interest rate. So the next one is 5. You put 5 in, they match. So you get the answer, right? So even you don't have a financial calculator, well, it takes you, let's say, 1 more minute, right? But you will be able to get the result. I think this we did, right? So this is this. Okay. So basically what we do is Brian receives an annuity. So Brian is an annuity. So this is 1 minus 1 plus, or you can keep V negative N divided by I. This is only 40% of the total perpetuity. Perpetuity is 1 divided by I. So from here, you know the discount factor is 60%, right? And what we want to know, we want to know Jeff's share. Jeff also receives an perpetuity, right? But it's deferred by 2 years. So Jeff's share is a perpetuity, but it's deferred by 2n years, right? He needs to wait for Brian to correct the first n and Corinne to correct the next n. That means 2n years has gone by, right? So we need to discount by this, and then he will correct the remaining ones. It's also a perpetuity. So what you get would be 60% raised the square, right? And this is what you know, what we are looking for K. A person age 40 wishes to accumulate a fund for retirement by depositing amount X at the end of each year into an account paying 4% interest. At age 65, this particular guy will use the entire amount to purchase a 15-year 5% annuity immediate with annual payments of $10,000 fund X. Okay, this is not a trivial question. So first of all, it's for SOA questions, they always have some agent or some person, some individual given certain age. Okay, so what means is when we say a person age 40, what we implicitly assume is this person just turned 40. So right now he is at this point, right? In our timeline, the number always means the end of that particular year. So in this dotted line, what I mean is he just finished, or he just spent his last day in his 39th year. So at this time, it is the beginning of his 40th year, right? That's why when we say a person age 40, we are somehow at this point, okay? He wants to accumulate funds, so you need to make deposits, okay? So here is money into the account. We don't know. We know it's X. We know he will continue this until what age? At age 60. So basically, he will continue until age 64. That is because starting from 65, he will need to. He used the money from this account to buy. And the payment will be $10,000. Okay, so that is the setup starting from 65, and it's a 15-year annuity. Okay, so you have 15 payments. Okay, now let's analyze. Okay, so basically in this setup, this person finances his own spending, right? So from 40 to 65. Okay, so what this person does is to deposit money into his account, right? So the first thing is how many deposits he's going to make, right? So it will be this number minus this, and the question is, should you add by 1 or not, right? So what I always suggest you is, if this is somehow a long range, right? I mean, counting fingers probably it's not the best choice, right? So pick another one. 40 and 45, how many payments, right? All of you should know, right? One payment at 40, one payment at 41, that's 2. How do you get 2? 41 minus 40 is 1. Right? 1 plus 1 is 2. So means you are going to plus 1. Right? So you get, so he deposits 25 payments, and he used the money to buy a 15-year annuity. So that's 15 payments. So, okay, you start with this, but we want future value. So now, where you are at, the future value will be the value at the end time. So he pays at the end of each year. So this value will be at time 64 or at age 64. Okay, so at the end of 64. So now I claim this value must be equal to the present value of the annuity immediate. So now the interest rate is 5%. Again, this value is the present value. The present value of an annuity is the value at the beginning of this annuity. Okay, so the beginning is here, although the first payment will be 65, right? Because it's an annuity immediate, you can think that way, right? Annuity immediate is paid at the end of that year. So if you want to convert to the very beginning of this annuity, it will be here, right? The beginning of year 65, which is the end of year 64, right? And this question is somehow friendly, so there's no gap. I can ask you a gap, right? So this guy pays annuity, makes deposits until he turned 65, which means it's here, right? Turned 65, which means he's at the end of age 64, and then he wait for 5 years. Okay, after 5 years, he thinks now it's time for maybe he was overspending in this 5 years, so he thinks it's time to buy an annuity. Okay, you have 5 years gap. So what are you going to do? If that is the case, you're going to do times by 5 years, right? So that's something, it's slightly more difficult. Solving this question is quite easy because your financial calculator can directly get this number, So it's a trivial question, right? Once you establish this equality. What if not? What if not? Then you need to write down the formula. So it's not that terrible, Once you do it a few times, everything should, flow easily from you. Right? And then you can calculate, okay? What I have is this number. So X is about 92. Again, it's none of these matches the result. So I pick the closest one. We are at the final question of this practice. So which one of the following are equal to 1? Again, you see, some of those concept questions you don't really need to calculate, but they can be tricky. It's we just like the SOA exam, we have all multiple choice. So if you are right, you are right. If you are wrong, you're wrong. So for this type of question, most of the time, what I see is you get partially right. Okay. Well, unfortunately, partially right in our case means 0. Right. So there are 3 options. Sometimes you understand 1, understand 2, but probably not 3. So that's why this type of question you actually need to be very, very careful. Which one of the following are equal to 1? We actually take this opportunity to learn a little bit more of the annuities. Okay, let's start with the first one. It's rather complicated, right? So the first question is, where do you start, right? You always start with something, or not always, or you try to simplify the complicated part. In this expression, the complication comes from this part, right? So let's say what is that? So the bracket equals right? So I simply apply the formula for the accumulated value of annuity immediate. So I cancel I, okay, I can further cancel 1. So this becomes this, right? So that's why, this type of question is tricky. They test you a little bit more, right? They don't directly put you 1 plus I to the 10th, right? They give you this complicated formula asking you to simplify, okay? And then what do we have? This is nothing but the future value, right? You have a present value and you times by an accumulation value factor for 10 years. That's exactly what you get, right? Because your annuity has 10 years. So it goes to the end of the annuity. So that's the AV formula, right? So that's our numerator. Now let's study the denominator. 1 plus this thing. 1 plus, this is the future value of an annuity due. Okay. If you don't see what's coming, you can try to here. So first of all, it's 9. So the first payment is at 0. The second is 1. The last payment is at 8. Right. So now what you want? You want to know what you get at the end of this annuity. At the end. So let me use blue color. So this refers to the value at the end of this annuity. So it's the end of the 9 years. Although the last payment is paid at 8, excuse me, because that's the beginning of 9. So the first payment goes to here. I need to accumulate for 9 years. Okay, goes on, and the last one only accumulate for 1 year. Okay, what is this? 1 plus I plus goes all the way to 1 plus I to the 9th. Right. So now let's draw another timeline to help you understand what is this. Okay, so let's study annuity immediate. And we want to know the future value. So this is 1, is here, okay? And this payment, if I want to move to time 10, I need to times by 1 year factor, which is here. It goes on, and this I need to times by 9 years. So this is nothing but the future value. This. See, now they match, obviously equals 1. So the first one is correct. The next one, we have a discount factor times by the future value. Then you go back, right? So this part is very, very easy. This is, right? So at least you should know this formula, right? So if you times by 10-year discount factor and your annuity has 10 years, that means you go back from AV to PV, right? So from the accumulated value to present value, okay? And then we are trying to do the subtraction. Will that subtraction be 1 or not? So if you're not sure, simply write down what is this. This is 1 plus V plus V square goes all the way to V the 9th. Right? Again, if we already have the somehow the timeline, we just need to add one more payment down here. Right? Now we want the present value, so it's 1. The second one is to times by 1 year factor. The third one times by 2 year factors. The last one times by 9 year discount factors. Right? So this is the annuity due, the present value. What would be this? This will be the first payment. You need to discount by 1 year. The second one, 2 years, goes 9 payments. So what is the difference? It's exactly 1, right? So this is also, the second one is also correct. Now let's analyze the last one. So the first part we can easily handle. So we have a present value, you times by 10-year factor. you move to this guy, right? And we want to know this minus this. Well, we just did, right? So we know this is here. What do I have? Here it's the S10, and we want to minus this was here. So just remove this one. What you have? They are exactly 1, right? Because according to what we just did, right? This minus this obviously is 1, right? We already did from part 1, so all of them are correct. Okay, that's the end of the practice questions. Now it's to see whether you have questions. So if you have a question, feel free to unmute or type in the chat room. So the actual exam will be quite similar to the practice. Some slightly more complicated, some maybe easy, maybe even easier. So, but generally, it has the same level of difficulty as the practice questions. You will, or I will expand the basic questions at least by 2. So let's say here, if you feel comfortable with 6 or 7 questions, you should do very well for the actual exam. So let me first stop the I think I'm doing the recording, so let's see whether let me stop it. Otherwise, the file